So for the panel discussion, you have your previous speakers, and then we have three new people. So Steve Kadis, and we've got Rachel Zweig, thank you. And we've got Manoj Shukla. So we're probably going to have them start by introducing themselves and what they do and who they are and how they do carbon management, and then we'll have some questions for the panel.
Hello, everybody. Steve Kadis. I'm here representing, I guess, myself. I have my own consultation business, Soil Health LLC, and I also work for the New Mexico Association of Conservation Districts. Retired from NRCS about a year and a half ago, and now what I'm doing is I'm working with conservation districts and producers, and also New Mexico Department of Agriculture, doing soil health planning. So this last year I did a lot of soil health conservation plans across all the way from the top of New Mexico all the way down to the bottom of New Mexico and everywhere in between. So about 15, 18 different plans with that. So getting a feel for what people are dealing with when we're talking about soil health planning, and trying to influence them and show them how they can improve their soil structure, their soil health, and to basically build their organic matter. So I do that and a number of other things, but my passion is in soil health. I do training in soil health and a variety of other things, and without going on and blabbing on for too long of a time, that's just a quick overview.
I'm Rachel Zweig. I'm the agricultural extension agent in Sandoval County, and I did a master's of soil science in Wageningen University in the Netherlands. And then I've also lived in Morocco in the desert and worked on some farms there. And then I'm from Arkansas and worked on a farm there. So had a kind of different climates, different regions, experience in agriculture. And so, I mean, my main interest is working with farmers to try to do practices that conserve the soil and water at the same time.
I was at Wageningen in 1992. And I can still not pronounce Wageningen.
It took me like half a year.
Yeah. So I am Manoj Shukla. I am a professor of soil physics at New Mexico State University, and I am also the director of the College of ASS Global Programs. Back in 2000, I wrote a grant proposal with Professor Lal, and rookie's luck that DOE funded my project for $800,000. And then at that time I worked on carbon sequestration, especially on the mined areas of Ohio. And those were, some of them were mined and never reclaimed, because if you know the history of the mine land reclamation, the first law was initiated by Ohio in 1972. And of course, after 1975, the federal law became active. So at that time, there was a lot of potential, not much work was done. So that was the huge grant, we got it. And then we also looked at, carbon sequestration and potential in other cropped areas. But then when I came to New Mexico, I am still looking for carbon in our soils. So I decided, maybe to pursue other, water-related projects. But for the last 4 or 5 years, one of the produced water companies, they came and they asked us to do some work for them on carbon sequestration, and probably later on looking on the possibility of using some of that treated produced water to increase the overall carbon sequestration. So we are in the first phase of that project. And then, as you know, water is a big problem for us here in the New Mexico. So NMDA and the Interstate Stream Commission both started working on the, we are not supposed to call the land fallowing, is leaving the land uncultivated. And that project also has this component of, and some of the things we saw, the previous speaker talked about how when you leave your land uncultivated, you save on the emissions and what could be the equivalent carbon of all of those things. So those are some of the aspects. that we are looking at growing the crop once and then, leaving it, all the biomass onto the field and see that, over time, 3 to 5 years, does it increase carbon or initially increases, then decreases, whatever happens to that, so that, we can come up with probably much better land fallowing techniques. Because, we have a big dust problem here in New Mexico, so leaving the land uncultivated has its own potential problems other than carbon and soil health. So, with regard to those projects, these two projects, I am little bit looking at carbon sequestration and soil health. And of course, I'm working with John Idaho, who is here. Rajan is also there, he's also part of the that NGL sponsored project.
So one of the questions that I had for Rajan, probably to get us started, and for the group here, is what's the current status and plan of the carbon management projects? Do we have new proposals that we need to put in? What is the outlook for the next year or two?
Yeah, right now, we are working on this first phase of funding. This one will go until next year. So on this first phase, we want to collect a baseline soil carbon data. So currently, we are working on different science centers across New Mexico, right? We have baseline data collected from Clovis Science Center, Clayton Science Center, Las Lunas, Farmington, and then Land Acre. We have different projects going on, but with this baseline data, and then in last meeting we collected some questions. We are in the phase of collecting what is the priority, what kind of project should we plan to help New Mexico farmers, New Mexico stakeholders to work on carbon management, carbon sequestration, or reducing greenhouse gas emissions. And then we will apply proposals to different funding agencies. But right now, I don't think on this cycle, as this team, we are working on different proposals as a different subgroups, but we are also looking at the big questions like what we can do as this group. Did I answer?
It sounded like you're in your final year or 2 years of this project. Is it going to continue on?
This is a 2-year project. We are on first year, second half of the first year. So by the end of the project, we want to get more funding and then continue. At this point, I don't have a clear picture, how much funding we will get and then where we go. But we are working on different proposals, applying different fundings with, not like all 18 people, but some of the subgroups. And we are getting some fundings, but the overall goal is to maintain these sites and then at least collect a minimum data set to get that 5-year, 10-year data on carbon sequestration, and then range of management practices. From Clayton, in Clayton, we are talking crop livestock system, crop only systems in Clovis, more irrigated crop systems in Land Acre, and then other land use in other science centers. And also rangeland, we have couple projects in progress.
Right, so one other question I had for the panel, listening to the presentations today or thinking of your own work, what would you propose are research questions that we should try to answer in the next 2 years, especially if it was something that was triggered by what you heard today?
Research completed in 2 years?
research that you think we need to pursue? So you heard something today and like, oh, we really should study that.
The first presentation that we heard this morning on the overview, the cropland, the rangeland, the forest, the one thing that struck me was, and I think Matt really summed it up when he said, we need to start thinking about carbon stability. And let this idea about carbon sequestration actually pulling carbon out of the atmosphere and storing it in the soil, let that one go. But how are we, in New Mexico, and especially in the arid West, how are we going to keep the carbon that we have now in place going forward? Because under any climate scenario, we're losing. You know, you took that, if you look at that last 30 years of data that I presented, or that last 30 years of climate, we've lost carbon everywhere, no matter what we did. We've lost carbon everywhere. If we just sent that forward 30 years, I think the probabilities are that we're going to lose carbon everywhere, no matter what we do, based on current business as usual. So I think the biggest priority we could do as a state, and the state's getting ready to do their plan, the most important thing we can do is figure out how to keep the carbon that we've currently got where it is and not lose any more.
Well, I'd say kind of onto that too would be really, since it's the vegetation that's going to put the carbon into the soil. We're going to get less precipitation. It's going to get hotter. So how do we, if we're like select for plants, do we breed for plants that will be able to survive in the future and maybe even fire resistant? So I think a lot of, you know, the plant research more into plants will really be beneficial for the soil.
Yeah, I could continue on that one. I don't know if this is more important, but it's part of this puzzle that we need to definitely improve our ways of quantifying the carbon in the soils and in the systems, make it easier somehow with new technology to actually measure, and then the verification. The calculations are, you can get credits, but the calculations vary, as we heard in the talks, and understand building up a system that actually is robust and takes into account the parts that need to be taken into account in a holistic manner in calculating, that is important, and especially, as was mentioned in the talks here, for the arid areas, because most of the data in science comes from the more moist areas where there is usually bigger cities and more money. So.
Yeah, that is a very important point, because if you look at, there are so many oil and gas companies who, instead of working in some other country, Africa or somewhere else, and then getting the carbon credits to compensate for their emissions here, they are highly interested to work here, right here in New Mexico, because we do have a lot of potential. Just looking at our rangeland and the pasture land, those are over 50%. But one of the major challenges is how to quantify the carbon. And then the second thing is that, is carbon sequestered in Ohio versus carbon sequestered in New Mexico, are they the same? Okay, you can always argue that, cost of water is almost nothing. But yeah, it is not really costly here, but the way we are having the water scarcity, that is going to be a big challenge. But when you look at the carbon, number one, if we are only looking at the soil organic carbon, it's a very dynamic system, which, you cannot say that we will not sequester any more. It's a dynamic process. We will sequester, we will lose. We'll sequester, we will lose. So basically, how much can we compensate by sequestering more as compared to losing? So that is the aspect we probably will need to focus on, in my opinion. Are there improved techniques, which can it's very hard to stabilize the carbon because that is only stabilized in micro aggregates, and unless and until you have a lot of carbon, you're not able to produce those micro aggregates. But yeah, definitely that is some of the very important aspect. How can you stabilize it, and and how can you really verify it? Because John has a very important question which probably nobody in the world can answer. How many samples does it take to have a good estimate of that? But this is not the conference on the other carbon that really dominates New Mexico or all the arid regions of the world, and that is the pathogenic carbon. Because when we grow plants, it also takes CO2 and directly sequesters into calcium carbonate or other forms. That is probably one of the most important thing. If we start losing that carbon, then we are completely lost. So the soil organic carbon is a very small pool when you are talking about arid areas of the world. It's really the pathogenic carbon, which is the very large, several hundred times larger than the soil organic carbon. So I think probably we'll have to look at all of these dynamics together. And until and unless we find a very reasonable way to quantify and assess properly how much carbon is in the soil, we are really probably not doing a good job in terms of even talking about the sequestration potentials, because sometimes when you look at the sequestration potential is 60 petagram of carbon per year, but then sometimes it has a standard deviation of plus minus 40. So it's a big challenge. How can we conclusively say that we really were able to sequester carbon or not?
So I don't know if I'm going to answer the question or not, but I'm going to come from where I'm working. I don't really work in research. So I'm working really with farmers and ranchers and people that have pastures and those types of things, applying the practices, the practices and the science that Dr. Gamiri and Dr. Ido come up with, and applying those practices and those basic things that we've talked about today, no-till and crop rotations and pasture planting and those types of things, cover crops, of course. So the problem that I see, or one of the things that I see that's most prominent is working with these producers, is they have limited knowledge on soil health. They know that it's important, but their knowledge is limited. Even the leaders of the conservation districts, their knowledge is limited in that. And even more than that, the equipment that people need to apply these practices is not available to those farmers. It's expensive for them to go out and buy a no-till planter, to do these types of things. Okay, so I see that as a roadblock right there, because we will design conservation plans, soil health management systems, but they don't have the equipment to do these things. There may be equipment, somebody may have one that's certain long distance away, or they may not have it. So they're limited to applying these practices just because they don't have the equipment around. And so I see that as one of the biggest things to really getting carbon into the ground or really building the soil that's out there. One of my goals is to work with the conservation districts to have them become more active and more proactive in looking at how can we get equipment, how can we get soil health systems on the ground in our county or in our local area, and get that information and training and knowledge to those producers. So anyway, that's one of the challenges, or one of the main challenges that I see in the work that I do. I know it's not exactly the question you asked, but it's where I'm coming from and what I see with the people that I work with.
And actually, there's some industrial engineers who would love that question, because one problem that they work on in research is equipment, custom harvesting, equipment placement and scheduling, and how many pieces of whatever should we have and where should we put them and in what order should we visit which farm. And so those definitely are research questions that can be answered. But I don't think we've spent much time on them here for these kinds of applications.
Right. There are a number of districts in New Mexico. There's 47 districts, and I would say probably about 5 of them are very active in soil health. And of those, in those 5, they do have equipment. They do make that equipment available, but not all of them are there. And so I'd like to see the rest of them at least rise to the level that these 5 leaders have. So I think there's a lot of potential, a lot of opportunity for districts to rise up and help producers with that. And they'll need funding for that.
Yes, and that's kind of a question for any kind of new agricultural practices like the agrivoltaics. It's exactly the same problem, because you will need to have, depending on what kind of a solar panel field you are dealing with, you might need to have special equipment for that. And then you need to have a community that actually can use them, because they are too expensive for most farmers to own alone.
Yep. Yeah, just a question. Looking at the practical side, I mean, we work in extension, Rachel works in extension. You know, the problem is, how do you incentivize the farmers to practice better soil health management or sequester carbon? You know, well, you can talk of carbon trading and all the rest, but with many of these farmers, it's not going to cut it. You know, they're looking for something they can gain in the short run. They're looking at their bank balance next year. They're not waiting for 10 years. You know, I remember, I mean, I always tell the story, my first convert to cover crops. You know, I preached cover crops for a couple of years, and I finally got one of the farmers, one of the largest farmers in the state. He said, yes, I'm going to do cover crop. I jumped up, I said, yes, this is a big fish. And this guy, you know, I put several acres. I mean, he planted corn silage, and then he no-till drill winter cover crop into his corn. I mean, after the corn silage, I was so happy, and I took a lot of pictures. Was going there from time to time, and then when he got to spring, I normally call him before I go to his farm. He stopped taking my calls. I called him. I thought I had offended him. Then finally, after a while, he took my call. He said, John, sorry, I'm sorry to disappoint you. He said the cover crop was darn good, and I had to cut and bale and make money. He said, how can I? He said, I paid for the water, I paid for the seeds, I paid for I paid for everything, the cultural practices, and then you want me to put it back into the ground. He said, no, I'm not doing that. That sounds foolish. And only God knows how much he made. Made a lot of money. So what you know, when we're number one, we're dealing in New Mexico with a lot of small farmers in terms of, I mean, this guy is even a very rich one. He's a multimillionaire. Even then, he's not ready to think about soil health. Then talk less of small farmers that are, you know, struggling there. So how do we incentivize them to practice better soil health? You know, that's one of the general questions I want to put to the panel. You know.
Well, I would say some of it is finding those farmers who are willing to take the risk just because they appreciate the importance of soil health. So, for instance, there's a alfalfa farmer, up in Peña Blanca, and farming's basically his retirement job, but he's really trying to do everything the most sustainable, and so and he said he's convinced maybe one of his neighbors to try to do a farm organically, but I mean, we know farmers are really entrenched in their way, so it's going to take time, and finding kind of like those lighthouse farms that can demonstrate that there are actually financial benefits in the long run if you do this, and then also just getting the new generation of farmers who I think have grown up more with the awareness of climate change, and so are more willing to try new techniques and break with 4 generations of practices.
I disagree a little bit. A good question, and I think that is the question. is how do we get people to adopt this? And typically we've done this via these programs. And like Matt said earlier, between the infrastructure bill and the Inflation Reduction Act, man, there is money coming into this at a level that I don't think we've ever thought about before. And we're not sure what to do about it. And we've typically sort of relied on the thing of, okay, if we can sort of do these things and we can get somebody to adopt this practice, and then it works and everybody sees it and they'll go, okay, well, we'll do it, and we don't actually have to pay the money because it's so obvious to people. Well, I mean, we've been stuck for 50 years at adoption. We're about 20, it doesn't really matter what the practice is, whether it's tillage practices or rotational grazing or anything else. We're kind of stuck at 20% of adoption. And people do it and they do it okay, but it's just not compelling enough to people that they say, well, I'm going to adopt this without any incentive. But we're going to have that incentive now. I mean, I think we're really looking at a situation where we might be able to raise that up to 50% just based on incentives and saying, here's the money. And I think it's important if we're going to have that kind of money and we do this, that we need to make sure that we spend the money on management practices every year, not on building fences and one-off type activities, so that we can actually go to individual producers and say, all right, you're going to get some incentive money and your risk is going to be covered. So we give you 10 years to figure out how to do this, and if you can do it, then you'll adopt it. But that transition cost is too high, and the risk is too high for people to adopt it without somebody that already has a lot of money. But I think we got the money now to do it.
I think that's very, very important what you said there, because there has to be a kind of, somebody must have to take the risk away. And I think that's one of the things that's why CRP worked, because there was somebody taking the risk, and I think that without that support.
We paid 10 years of,
yeah.
We had 10 years of rent.
Yeah. So without that kind of incentive, the only people that will be adopting, Rachel is right in the sense, I mean, that's the same experience I have. The people that are interested, I mean, they're naturally motivated. I don't need to preach to them, maybe they've read up or just the way they are, so they're adopting it, doing it. But a general population, we're talking of around 90% of producers, they're not ready to take the risk. Mm-hmm. Only those 10% that are very self-motivated, those are the ones we are seeing that are doing all these practices. The rate, I mean, if you go and ask, the rate of adoption of no-till or cover crops in New Mexico is still very low compared with some, go to Midwest and all the rest. So I think that incentive probably is going to help with a better adoption of, practices, within our state here. Yeah.
And along those same lines, I think that the incentives, we have to approach it baby step, especially with people who are not entrepreneurs or who aren't the leaders, to take a baby step and to start small and to start slow. Because going into a soil health system is new. Many farmers know how to do all the basics, to plant and to harvest and to control weeds and things like that. But just to introduce a new technology, it takes starting at it slow, and you don't want them to engage or invest in their whole property. And I'm talking like small acreages, 5-10 acres on a larger farm, so that they can try out one piece of this new soil health technology, whether it's a cover crop or whether it's no-till, so that they can work with that and get to be familiar with what's going on and see the unforeseen limitations or challenges without investing a lot of money, but also so that when they do these things, they can see the benefit on a small scale and then be more confident to take that technology and then expand it a little bit larger and prove to themselves. I think that in itself is an incentive, just to start slow and start small and then to build on that. I think that soil health to a lot of people is still a mystery. And so the mystery is only uncovered when they start practicing it and doing it, because actually soil health and putting these things on the ground is a very personal thing, and it's different for every person. We can talk about methods and principles, but until somebody applies it, it doesn't become personal. They don't have any skin in the game. But once they have that skin in the game, they start to learn from themselves.
I was listening to Breck's presentation and thinking about what resources NMSU has. And one thing that struck me from her presentation with the description of Agora's models is the farmer does almost no paperwork. Did you notice that? The Agora agronomist comes to the field, looks at the records, they fill out the paperwork, they do the soil sampling, and they write up the contract. But the farmer doesn't have to interact with the carbon markets. And I'm wondering, I'm thinking from NMSU's perspective, what can we do to help what I see are two big uncertainties if I were running a business? One is modeling the cost of, I know at NMSU we have agricultural economists who calculate what happens if I put in irrigation, what happens if I switch to this crop or this crop. Do we have an agricultural economist who can calculate soil health benefits and carbon? Should we get one? Or should we ask the state for one? Where that is what they do. Second of all, to what extent can we help farmers with the paperwork of knowing, I know how difficult doing taxes can be when it's your own business, or heaven forbid NMSU accounting. But to me, one of the barriers would be, oh, this sounds cool. All right, I found someone who has the equipment. I think I could do the practice. What do I do with all these forms, and who do I give them to, and how do I make a decision? And so maybe that's one suggestion that we could take to either to the state or to our administration is someone to help with that.
And did she also say that they have a 500-acre minimum before they'll? So that's something else too. If you can have like a cooperative of farmers, 'cause, like, around here, they're small fields. So if you can get farmers that will band together, that'll be tricky because you have to get the buy-in from every single one to continue the practices. But that can be another thing to look into.
Yeah, and this is how the carbon trading actually works, that the independent organization, like in Ohio, it was the Chicago Carbon Trading Company, they will come and take these samples because they really want to make sure that farmer has no role in actually assessing how much carbon was sequestered in that farm. So this is all done independently. The other thing is, John, you have raised a very important point, and just let me tell you, when I was working in the Clark County, South Charleston of Ohio, what we have seen that it's not easy to change your way of doing things if you are doing it for 40, 50 years. So that's what we observed, that especially these younger new generation farmers, when they took over the farm from their parents, they were the ones who really went into no-till almost immediately, because they were immediately calculating that, hey, look, if I am not running my tractor so many times on cultivating the land and other things, so I'm just saving on petrol, gas. So that was, their very first quick thought about it, and they moved it. The other thing that I saw a big expansion was that these young farmers were not only farming on their land, but they were also leasing a lot of land. And therefore, you can very distinctly see that, there is a farm, On one side of the road, a very large farm which is under no-till for 10 years, and on the other side of the road is a farm which is tilled several times every year, because the other farmer, he says, you know, this is how I have done it all of my life, and I am earning good profit from my farm. Why should I change? And yeah, as a extension worker, when you are talking to that farmer, you really don't talk about the no-till. You sit with him, talk, drink beer, and come out. So that is the one thing. The other thing is, but New Mexico has some special problems. You just cannot practice no-till if you have a heavy textured soil, because that heavy textured soil versus, you know, whatever small precipitation that we get, we really want that water to somehow seep into our soil. So you really need to till your soil little bit, you know, and so that luxury we do not have on every single farm, especially whenever you look at these farms which are located around the Rio Grande River, which are some of the most productive lands here in New Mexico. Majority of them are seated on heavier textured soil. So that's the you know, so whenever we are trying to tell our farmers, we will have to really be very clear in articulating it, that we understand your limitations with regard to the water availability, with regard to your, you know, soil type and all of those things. And I really 100% agree with you that it has to be a self-motivated person. The person will have to be self-motivated, because you cannot expect to get a very large sums of money from a very small farm. So it's much more like you want to do that, not for money, but you just believe in that concept, or you just believe in trying something new, whether it is successful or not.
Yeah, I'm going back a little bit to what Katie was talking about, this service that we could provide, and I see value in this kind of a modeling service based on like from a university or for the state that is in a certain way an independent player. Because if the modeling is done by the company that produces the incentives, there is immediately a conflict of interest in that. So in that sense, like again, third-party verification from outside, even for that one, would be useful.
Can I ask a question? My question is, means there was a lot of talk about crop diversification. How much Farm Bill plays a role in limiting carbon sequestration? Means, Dr. Shukla mentioned farmers are complacent, especially old farmers. They don't want to change because Farm Bill protects them whatever they do. So they don't want to grow legumes. They don't want to grow any new crops that may be water efficient. So any comments on that?
Yeah, first of all, I want to make sure that people understand the Chicago Climate Exchange was not trying to make money on carbon. They were trying to make money on transaction. It was an exchange. What we've got now and what the presentation today was, they are trying to make money on carbon. They're not trying to make money on the exchange. Those are two completely different things. And I think that sort of makes a difference about what technically we can do with research on it and helping people understand what those differences are. The second part of your question is, the Farm Bill is still going to be about producing 5 commodities. And you know, we're trying to increase the importance of carbon and other environmental ecosystem services, but it's a hell of a long way between where we are now with trying to guarantee through insurance and all of that yields of 5 commodity crops versus trying to improve the environmental quality of farming. And at some level, those are competing and almost opposite goals, but they're maybe getting closer together, but it's still a long way off.
Yeah, maybe I will add a little bit on the earlier discussion and then on this point also. I don't know how much of the misinformation we see on the internet also, that is playing a big role on this adoption, non-adoption thing. When those commercial, talking about big potential of carbon sequestration, and then when, farmers jumps into it, in tries couple years, he sees nothing in our environment. So, having that realistic data and then communicating that information, what is our limit, what we can do, what we cannot do. I think that has a big role to play on adoption. I see, on the cover cropping, there are farmers, they come, ask, and then try one season. They want to see the benefit, they see on that 30-second video, they got like, oh, I got this much carbon increase, all those, and then they see nothing on their field, and then go back, oh, this doesn't work. So I think the providing a realistic information, what we can get New Mexico or in our environment, that local area. So that is one very important aspect. And then another, in that policy side also, it is very interesting on the policy front. We work on the soil health bill that incentivize soil health practices. And then after a couple of years, it come into this land fallowing bill. You incentivize fallowing also. And then those are just opposite two things. These policies doesn't work. And I don't know like who is the the driver on these policies. So I think we need to look into those. We just made that soil health bill, and then we incentivize opposite practices. That is also another cause of slow adoption I see because you get incentive for adopting soil health practice, and then you also get incentive for not adopting those practices. So that is.
If I just say, Rajan, on that, what I am told by the NMDA is that their aim is to find out the best ways to manage uncultivated lands. They do understand that if you are not growing any crops, then of course you might actually be decreasing the soil health in those farms. So yeah, the aim is really to find out the best management practices. How can you do that so that you gain net gain? Like for example, today's presenter was talking about that when you are not fertilizing, you are saving so many carbon equivalents of greenhouse gases and those things. So that's definitely the aim. But yeah, first time when I also heard about that land fallowing, and the same thing came to my mind, that really you want to improve the soil health, and how can you leave that land uncultivated? But then later on they explained that their whole purpose is to find out better ways of managing the uncultivated lands. Because there is a trade-off with water availability versus that. This year the water availability is much better. This year we have almost 16 to 17 inches of water that will be given to the farmers, as compared to previous years when we went as low as 2 to 4 inches. So that those are the trade-offs as far as I understand. But I really agree with you that long term there will be implications on soil health.
I think they are incentivizing, like if you stop irrigating the land, then you can get a certain amount of check. This the research front is really good. Understanding which practice works good, and understanding that. But the state is starting that incentive program to the farmers. Maybe that is more appealing than by the time we get the research data. This is the best practice. We lose X amount of carbon already. And then soil health, erosion, other issues. So this is I find that is very interesting, how the policy plays into the real context before the research data comes. That is that makes more confusing on the farmer side, what to adopt. That is where I am going.
Can I give one comment about cover crop, and then I will shut up, let all of you talk. Like John, I just want to give you an example of Oregon. In Oregon, you see, there are a lot of, fruit orchards. They produce a lot of different types of fruit and they sell it all over the world. And, many of those orchards are located on a slope. And most of them are sprinkler, micro sprinkler or sprinkler irrigated. And some of those places where, you are irrigating, they are so high that you have to literally push the river water all the way up to the hill. And then afterwards, you can use gravity to irrigate all of your farms. And the water also has a very low pH. So first, when you get that water, irrigation water, you have to first increase the pH in the tanks and then only you can irrigate that. But if you go and look at some of those farms, you will see they will have the grasses planted in between the tree rows, but the way they are utilizing their water and system, that you will not see that grass be always green. That grass will turn yellow because they have only one sprinkler for the grass and 4 for the trees. So, somehow most people don't accept when they see the grass or the cover crop yellow. But that is one sure good way of not only stopping the wind erosion, dust emission, erosion, but at the same time increasing carbon into the soil and simultaneously saving that precious water, which is not really available here. So I have no idea how we can convince people to probably, instead of using it as a marketable produce, if they can use less water and use it for improving the soil health.
Yeah, I have just a snarky comment here about, it looks to me that we are definitely building a market for consultation for optimizing your incentives in this system, and it's going to be as complex as the taxes. So.
Yeah, to answer Manoj's question, actually circular buffer strip is exactly that or even better system than that actually, because it improves a lot more ecosystem services. One farmer adopted 10 circles of it, but then gave up actually because grass doesn't survive in our environment. Means there was it didn't establish well actually. On Google Earth you can see nice circles of it, but grass didn't grow. So water, it can play both sides for us. We got 15-inch rainfall this year, and that hurt carbon sequestration than helping it actually. A lot of soil eroded in our research center itself actually.
Thanks. I'm listening for a consensus. Let me find my note. Oh, sugar. Hold on a second. Okay. Am I hearing based on the available data and collective expertise, that that we have a consensus that in New Mexico or in arid, semi-arid systems, we should, as Joel put it, forget sequestration and focus on carbon stability? Is that where we all, is that a take-home message from today for someone like me who's trying to reframe this for how to reach out to the public and almost like, it's almost like you can pepper these ideas, like kind of get it into the newspaper articles and circulate it, not as like a true statement, but as a maybe, or as a, this is what this group is considering.
I'm gonna give you the engineering answer is that we need all of the above. And that's something that's come up in the biochar world a lot. Because when biochar first came out, it was you do this and the world will magically change and everything will be wonderful. Mm-hmm. Forget the fertilizers, you just apply biochar and your life is perfect. And it's taken about a decade to change the message of you need to do this and. Mm-hmm. My suggestion for this group would be that we need a stronger focus on holding on to the carbon that we have. I think that should be message number one.
Yeah, thanks.
And we need to look at ways within our water limitations that we can add carbon to the soil, because there will be some unavoidable losses. But if we can have strategies to maintain as best as we can what we have, and use, I love the carbon per drop of water metric. I'm going to steal that one. If we can say, okay, we've got this much water to invest, where and how best can we also sequester carbon? That would be my suggestion.
Yeah, and I would even see that so that yes, we definitely need to do both. There is slightly less uncertainty in the unintended consequences for trying to hold on to the carbon that we already have than adding more stuff. So basically the overall whole picture, we are managing the risk a little bit better if we focus more on the holding onto the carbon, but at the same time we do need to do both. We cannot afford doing only one thing.
Yeah, I agree, because we really don't know accurately how much carbon we have. So if we don't even know how much we have, how can we claim that we were able to hold on to that amount? So
Yeah, and I find that several people have said we don't have the methods for collecting the data that we need. That's really disappointing, right? And how is it up to me, it's to put that on New Mexico researchers. It's like that is a worldwide problem, right? Yeah, so that's discouraging. I also wanted to, I'm thinking about resources for small growers, and I'm remembering the Organic Farming Conference and some of the panel discussions there. And that used to be an annual conference that was held in Albuquerque and was, to me, it seemed really well attended. And I think it was an NMDA project. And I don't know if anybody's heard if there's projects to bring that back, or if there's, yeah.
Yeah, I might be able to add some insight to that. So originally there was, and it might have been the Environment Department, but way back, the Organic Association started with funding through there. And politics in Santa Fe shoved it onto NMDA because they were agriculture, but it was never funded by the state. And so the whole organic program had to pay for itself. And over time, everything from the organic conference to the funds to pay for organic certifiers just became impossible to cash flow, because it was set up to where they were paying for a lot of the small producers to have their land certified, but that didn't cover the cost of the certifiers. And so it wasn't a program that could cash flow. And so NMDA finally dropped the program because they couldn't get funding for it through the legislature. And now I guess it's kind of on their own. The farmers have to go through independent certifiers from out of state, which pretty much puts it on the venue of the larger farms to get certified.
Yeah, thank you. I have like 2 questions actually. So is there a possibility of the industry and academia collaborating in terms of consulting? Because I know that industries like Agaro, Carbon Direct, they kind of like do a good job helping organizations they manage reduce their carbon and also efficiently utilize it. But we are struggling to get farmers to adopt, practices that would, benefit the soil and then the environment in the long run. So I don't know if there is a possibility of the industry collaborating with, okay, what are your strategies? Can we adopt such strategies? I know they might be different, but I'm sure that there should be one or two things to glean from whatever it is they are doing. Because I think academia, in academia, we need to be doing consulting too. I guess that's what they are doing a lot. We do extension, but maybe the consulting part of it with the incentives that you all have mentioned. So is there a way, or is there something like that already in motion? Is it, or can that be done? That's my first question. And then the second question would be to Dr. Gimere or anybody in the carbon management group. So in the light of trees saving the world, I know NMSU has, there's NMSU viticulture. I don't know if that aspect was evaluated in terms of how in vineyards, carbon sequestration in vineyards, were they quantified? Has there been anything done? Because there's almost little or no disturbance to the soil once the vineyard is established. Has that been quantified?
First one, and kind of in response to that overall question, thank you.
Oh, good.
I think it's obvious that the private sector has a business model for making money on carbon sequestration. If you think you got a model that will let you make money on rangeland with 12 inches of precipitation, you think you got it figured out. I don't think they need any help. Maybe the ranchers need help. I don't think we have a strategy for keeping the carbon that we already have in place. That's a public sector interest, I think. And I think that's where, as a group of academics and agency and so forth, I think that's where we can have an impact at this point, because the private sector's got a model. They know what they're going to do, or what they're going to try to do. I don't think we've got a very good way of communicating that strategy or the mechanisms that we're going to try to use when we implement it. So that's where I think our biggest potential impact could be at this point. And as far as the numbers, a lot of the data that we presented today, whether it was forest or rangeland or anything else, I mean, we showed a lot of stuff that was from the 60s and 70s. And there's no need in doing that again. Those numbers are good. I think we got plenty of numbers to come up with a good strategy. There's obviously, some modeling that would work, and like the forest fire modeling and stuff. There's, we've got some better tools now than we had before, but I think we've got the basic numbers that we need to start putting that stuff together. There's not enough that we don't know that should hold us back.
Yeah, maybe I will just add on that. Definitely, we should work more with private companies, to effectively disseminate that information. But this carbon market, and then the quantifying, all these things are evolving. I was working on a committee for American Society of Agronomy, Soil Science Society, those tri-societies. We wanted to access the different companies' business model. We at that time, that was 2021. We produced a comprehensive 30-page report about the different companies and their strategies. They are also grappling with a lot of uncertainty. The data we are talking, and then talking to Agoro Carbon, they are using some of the data we collected. I forwarded a couple of papers, that Oregon paper I presented here. Some of the papers we published from Clovis Science Center. They are still using those information to improve their model, and then look at their incentive, like how much they can incentivize. So in a way, researchers and then industry people are already working. And then we are feeding some information to them. Their information is, oh yeah, market is playing. Like why we need to collect a 30 centimeter soil sample. That is all coming from that industry and then research academia interactions, like a lot of data collected in last 20, 30 years. But we need more collaboration and then more, tailor our research program to help them, because when the money is on the, when they show money, then maybe that is the better attraction for farmer to adopt those techniques. I see that point there. Regarding carbon management projects, effort in the tree, I think we have a limited work on that. Our viticulturist quit recently, and then we don't have enough people working on forestry, agroforestry. So we have been, we discussed a little bit. And urban tree, I think Marisha is working on those, but that effort is not enough, and then we don't have a lot of people working on that.
An idea that just came to my mind based on something I've seen in engineering. So in our college, we don't do extension, but we do outreach. And one of the programs that we can do to support industry is we help people do energy audits. And so especially graduate engineers, undergraduate engineering students, they go to these companies, they have a form from the Department of Energy that they fill out, they take the measurements and they give the results, and then they help the business owners identify which DOE programs, energy efficiency, new lighting, insulating your pipes, all of that, help them figure out which things they can get money for, which things they should do. Could NMSU do a soil carbon audit program where you have a form and you have people who go take the measurements, help fill it out, and then identify which programs or which incentives they may want to pursue?
I did want to say that when I hear something like we need more consultants, I agree, and I cringe immediately because the extension specialists, there's no time to do hours and hours with a single client or right? And with the county agents, there's no time to do that. To me, the extension relationship, in order to help as many people as possible, should be more of, let me put you in touch with this resource. Let me share this resource on this has already been answered other times. And so I'm afraid that we don't have the time. So the idea of having a form where you can fill out, that's the first part I loved, but then someone who's going to go to each site and do the test, it's just like who and where's that money coming from? Could it be a grad student internship program where we have grad students around the state and you go home to your county and do 30 of these in your summer? I don't know how that would be possible, but there's no time.
One thing that one of the reasons Rajan had me up here is I was supposed to brainstorm ideas where engineering could be more helpful here. And engineering students are always looking for internships. And we love forcing them to take measurements and do calculations. It's our favorite thing. This might be one area that they could help. And maybe this is something we seek for the funding, are these internship programs where we'll train you on how to take the measurements, go forth and work with our stakeholders.
And time is definitely, I understand, what you are saying it. But the other, probably the more important than time is the quality of sampling. You cannot, people think soil sampling is very easy. You can just go collect a sample. It's not. It's not, plus human errors are there. If you have 50 people, there are 50 different types of errors. If you have 5 people, then there are 5 different types of errors. Plus, where do you analyze your samples,
Sure.
And so again, you send it to 6 different labs, you get 6 different answers. So
And
it's
6 different fees.
Yeah, and 6 different fees, yeah. So it's a very complicated system. It's very easy to say, but it's a very, very complicated thing, especially if you really want to come up with some real good estimates and for a future policy decisions or something.
I have the microphone. I have another question, and pardon my soil science deficiencies, but imagine that I'm just general public asking this question. So if measuring the carbon is elusive and difficult, are there indicators that mirror soil carbon? Is it as simple as soil organic matter? Can it be? And in terms of tracking changes, and maybe, am I just thinking that there's an easier answer and y'all have already decided there isn't? Or, yeah. Yeah.
Is it now? Yeah. Okay, so that's an area of active program development at LANAL and elsewhere too. And there are some spectral methods that could be used, but they see only the surface. And then in field conditions, my dream is that we could have an app on our cell phone and use the cell phone camera to actually measure it. Any farmer could measure it for themselves and then put it into some kind of a program online, calculating what theirs is and see it there. We are not there yet. But I hope that I one day will get the money to actually start doing this kind of work and researching the alternative methods. We do have some indications that using, for example, LiDAR data for about point clouds of vegetation in certain ecosystems can indicate how much carbon there is in the soil. But that is, again, it has been tested only in very few ecosystems, and you don't get the deeper soil. You get basically the active layer on that one.
So going back to the first question, areas that we need research on is how to make soil research easier, because soil is just so notoriously hard to study because it's so complex, you can't see in it. So that would, I think, go a long way to solving a lot of other issues.
Thank you, Marissa. You asked my questions for me. but what I was going to say, and something that, so I'm the range specialist, so I'm pushing people get out and monitor their rangelands. And one of the first things, the issues we have, so I'm getting a feeling that the end result of what we want to get is change, whether that be changing them into a cover crop system or some sort of change to a rotational grazing. What I faced is when we have that, when we're trying to focus on that sort of objective, we need to go backwards a little bit, because in order to measure change, you need to have some sort of database to look at trends in the information. Do we have that for producers and landowners right now? I don't think so. And then going back even further, and we mentioned this, right? Simplicity. Do we have a uniform method to present to producers some sort of publication methodologies that we can hand out to producer to say, you do this to get your information, then you can take that information and put it into this database. From that database, you can see your trends, and therefore that incentivizes some sort of change. I'm not aware of anything that is set up to that point right now, specifically associated with carbon. So I think the questions you were asking hit right on the head of what I was going to ask, were those kind of along those three sort of lines. And since I am on the Healthy Soils program for NMDA on the board, I have to put a plug in for them, right? That's part of one of their objectives, is to develop some sort of simplified program to incentivize producers in healthy soils by developing a program just like that. But nobody's applied for that. So.
Well, one of the things I'm thinking is, especially when it comes to assessing carbon, I think probably one of the problems we have, like you said, is where sampling and cost, it takes a lot of samples to be able to realistically or reliably estimate carbon within a space. You know, I think probably we have to begin to think in terms of moving away from wet chemistry to spectroscopy. And a lot of work has been done by using visible near-infrared, mid-infrared, that actually gets carbon very well predicted. So, I mean, it will still take a lot of work, establishing a very good spectral libraries, across different ecosystem or major land resources areas. I mean, Dr. Colby Brungard is one of the persons that is doing that, and I think if we can move to where we can have spectroscopy, as a means of estimating carbon, then the only problem now will be taking samples, the cost of sampling, which is still significant. But at least we can cut back the wet chemistry, because once the sample comes in and then, it's processed well. I mean, processing is there too, because there are some things you need to do. And then, but it can be rapidly measured, with spectroscopy. Once you have your good spectral library and your predictive equation, boom, you can run 10,000 samples, within a short period of time. Okay, he's saying that it's time to, oh, okay, you need, okay. So that's just one of the contributions I have.
So building on what John said, Rajan, I have the proposal idea for you. That one of the projects we propose following on to this is the development of the spectral libraries in collaboration with the other arid regions. So our colleagues in Arizona, our colleagues in Colorado, our colleagues in Utah, California, and we do surveys across the regions on the spectroscopy of how do you measure carbon in these dry soils using spectral methods. And now they could be correlated to the wet chemistry, but the whole point is how do we make this easier, but it's got to be dry soils, not the lovely wet stuff that everybody else gets to work with.
Yeah, I'll just comment on that one, because we have a slightly different approach how we are trying to address this, basically trying to find above ground proxies for what is below ground. And it's kind of yes, there is again, like, you have to compare to the real measurements first, but you can have the direct spectral measurement from the soil, or you can try to have a proxy from above ground, from the vegetation.
Your suggestion will at least solve one of the question that was raised by rangeland scientists, that at least you have a uniform method of doing that. But then the whole question comes back, what type of carbon are you actually looking at?
Yeah. Well, I think, it depends on, hello? We can leave it on. I don't think it's affecting anything. We can leave it on. So I think it depends on how you tweak your spectroscopic methods. There are a lot of methods there. You can also use it to track inorganic carbon. You can use it to track organic. It depends on, once you take your measurements, then you just start doing this big correlation and, regression between, whatever you want to measure. I mean, Mohammed did some things. I mean, we used laser-induced breakdown spectroscopy and visible near-infrared, and everything was good for organic. We were even able to get very good relationship with microbial parameters in the soil, So it's possible. I think if that method is encouraged and scientists across institutions pull together and develop robust spectral libraries, like Katie is saying, across arid regions, and the data comes in and then we start using it, then it's going to make life a lot easier. It's going to reduce cost, at least the cost of wet chemistry. Of analyze right now, if you look at, the best method that people say is, for our soils in the western area is this Walkley Black, which contains very toxic chemical. And in fact, I think in California, they don't want it again. They banned it. So they are even moving away from that, and they're doing this dry combustion and all the rest. So, if we're able to establish this thing and come together and get this thing robustly set up, I think it will make life a lot easier, and we'll be able to take a lot of samples and estimate rapidly and get some results within a short period of time, rather than, you know, send your samples to the lab. You know, the turnaround period, I mean, at the peak period, at times you can wait a month or two to get your results, depending on how busy the lab is. But if we have this spectroscopy method, boom, you can generate a lot of results.
So
you have it already, just plug
it
in.
was brought to my attention that we are at 4:30. And so I would like to thank everyone on the panel. I don't know if we want to continue or adjourn for now and carry on conversations. So we'll give, Sana, you want the last word?
I don't know if I have a really big last word, but I wanted to comment on the data availability because that was one question about like is there data available? And from satellites there is quite a good coverage for vegetation cover. It's not necessarily on small farm scale. And for soil carbon there are estimates for countries, as we have seen maps today. Their accuracy at farm scale is very poor. So it's again like scaling issue. Yes, there is data available, but it's not yet really usable at farm scale yet.
Let's thank our speakers for today, and thank you for the organizers for setting this up.